Hello and welcome. It's your main math man, Mr. Lyons here. Hope all is well. We're on page 37 today, and we are going to discover a rule when it comes to dividing exponents. Now, this is literally one of my favorite lessons in this unit, and I want you to think about something. Take a look here, right? We're going to expand and we're going to simplify this. We're going to discover a rule, yada, yada. But I want you to think about this. 3 to the 7th times 3 to the 5th, right? We learned the product rule and how to get this. You guys know what the answer would be here, right? It'd be 3 to the, that's absolutely correct, 3 to the 12th. Think about why that is, and think about, since we're multiplying our exponential expressions here with common bases, what do you think we're going to do when we're dividing exponential expressions with common bases? Well, let's expand and take a look, okay? Make sure you're taking the notes that I take. This is going to be equal to, let's expand the numerator first, right? It's going to be 3 times 3 times 3 times 3, 1, 2, 3, 4, times 3 times 3 times 3, right? 1, 2, 3, 4, 5, 6, 7. Expanding it, exponents are repeated multiplication times 3. Look at how I'm trying to organize my work here, right? Times 3, 5 threes at the bottom, 5 factors of 3s. Now, there's nothing under these last 2 3s here, but if I wanted to keep it organized, what could I multiply here? And that would which would keep the same value of the bottom. What could I just add here just to multiply? Not 0, because then that would turn the denominator into 0. Multiply by 1, it'll stay the same, right? Look how I'm keeping my work organized, my factors organized. Now, another way you could write this here, some of you are probably already noticing a pattern. Another thing you could do here is say, well, 3 over 3 times 3 over 3 times 3 over 3. Go ahead and finish this if you can. Times 3 over 3 times 3 over 3 times 3 over 1. That's right, times 3 over 1, right? That's how multiplication works. This is another way to write these things because you're still multiplying all the way across, right? What do you notice here? Well, I noticed that 3 divided by 3 is 1. 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 So that's really 1 times 1 times 1 times, which is just 1 times, what's 3 over 1? Just 3. 3 over 1 is just 3. What's 3 times 3? Absolutely. This is just really 3 times 3 times 1, which you only really need because we know 1 times anything is itself. And this is going to give us 3 to the 2nd power here. Right? I hope that makes sense, right? When you expand, you get your ones, and then you're left with two exponents in the numerator, 3 to the 2nd power. Now look here, see if you can find a pattern. How did we get 3 to the 2nd power, right? We're not going to do this vocabulary section just yet. Let's take a look at example 2 right now, right? Let's expand this very quickly. Go ahead and pause the video and catch up to me. 1, 2, 3, 4, 5, 6, 7. 8, and then I have 4 times 4. Now, you can simplify this, right? You can simplify it easily. 4 divided by 4 is just 1. 4 divided by 4 is just 1. What comes down here? It's not going to be 0. Don't think this is nothing down here, right? Think it would have to be times 1, right? There's always someone there, right? Times 1, don't mind my emails, times 1. But we know anything divided by 1 is itself. So all we need to do is in our numerator here. What's going to be my final base and my final exponent? It's going to be 4 to the, that's right, 6th power. You don't even need to put it over 1 because, again, we know anything over 1 is just going to be itself, right? How did we get 6 here? Are you noticing a pattern? Think about it. All right. Look at example 3. Let's go ahead and expand this. Now, what do you notice is different here compared to these other examples? That's right. We have more factors in our denominator. This is going to be y over y times y times y times y times y times y, right? 1, 2, 3, 4, 5, 6. But just to keep things organized, don't forget there's always someone there. Now, what do you think your answer is going to be here? Go ahead and see if you can do this on your own before I go ahead and show you. Well, we know y over y. Anything divided by itself is 1. And in my numerator, what's 1 times 1 times 1? In my numerator, I'm going to have 1 here. What's going to be in my denominator? That's right. It's going to be y to the 5th power. I see some of us are catching on. Some of us are catching on here. I'm going to do this last one on your own. Pause the video, see if you can do this one on your own. Pause the video, see if you can do this one on your own, right? Here we have n times n times n over n times n times n times n. 1, 2, 3, 4, 5, 6, 7, just to keep things organized, right? You can just put times 1 because that's not going to change the value here. Times 1, times 1, times 1. Anything divided by itself is 1. What's going to be my numerator? What's going to be my denominator? Go ahead and try it on your own. My numerator is going to be 1. My denominator is going to be n to the 4th power. That's how we expanded. Some of you are probably already noticing a pattern here about what you can do when you're dividing exponential expressions with common bases. What is the pattern you're noticing? Just like when we multiplied exponential expressions with common bases, what did we do? But now we're dividing exponential expressions with common bases. What pattern do you notice? Okay, go ahead and fill in the vocabulary on the next slide, and I'll check you in a little bit.